So lastly, we'll look at how to apply U substitutions in word problems like this one. So here we have the marginal price P prime of X at a supply level of X tubes per week for a certain brand of toothpaste is given by this function. And we want to find the price supply equation. So in other words, we want to relate P and X if the supplier is willing to supply 100 tubes per week at a price of $3.65 each. So this initial condition here is telling us that with a supply of 100 tubes, that would correspond to a price of $3.65. So in other words, P at 100 is going to equal $3.65. That's how I would translate the underlined portion into an initial condition that tells you the relationship between the price whenever you have, well, I should say the relationship between the price and this initial supply of 100 tubes. And so we're first going to find the price supply equation because that's the first goal here, but then secondarily we'll need to answer this last question, which says how many tubes would the supplier be willing to supply at this particular price. So we'll go through those in a second. But first, let's just find P. So what we know is that P prime of X is equal to 0.001 e to the 0.01 X. And to find P, we know we should take an antiderivative. So P of X is going to equal an antiderivative of P prime of X. So I should say with respect to X here. So this would be the integral of 0.001 e to the 0.01 X dx. So now we're trying to find this antiderivative. Now in order to do that, here, because this exponent is sort of complicated, I'm going to treat that as my inside function. So I'm going to call that u. So I will say let u equal that inside function. That would mean that du is equal to just 0.01 dx. And again, because we're trying to get rid of dx, it might be useful to solve for this dx, or in other words, to isolate the dx. And to do that, you would just divide both sides by 0.01. So we can divide both sides by 0.01, and we would end up getting the equation that du divided by 0.01 is equal to dx. Or if you'd like, division by 0.01 is the same thing as multiplying by 100. So you could also write this equation as 100 du equals dx. So all of those are equivalent. But no matter which of those you choose, what you'll end up getting is that we're integrating 0.001 times e to the u, because u is 0.01x. And then the dx I can replace with its corresponding expression in terms of du. I'll just pick the last one because that's a little more convenient. So we found that dx is equal to 100 du, so this dx I'm going to replace with a 100 du. And now 0.001 times 100, that would end up just being a 0.1. And because these are just constant factors, I can pull them outside of the integral if I'd like. So that 0.1 I can stick outside of the integral by just multiplying these two numbers and then factoring that number out from the integral, and then I would get times the integral of e to the u du. That should be 0.1 e to the u plus a c. So we're almost done with finding P of X. It's just that we first need to replace u with its actual expression in terms of X, because we want this to be a function of X. So I replace u with its value in terms of X. But we're not quite done, because what we found so far is that P of X is equal to 0.1 times e to the 0.01x plus c. Now, to figure out the value of c, we need to use this initial condition that we have up at the top here. So what we know is that if we plug in a supply of 100, we know that the resulting price should be $3.65. So if I plug that in, from our initial condition, what I would get is that $3.65 as the p-value should correspond to, 0.1 times e to the 0.01 times x In this case, the x that we're plugging in is 100. Then we'll have a plus c over here. So this will be enough for us to solve for c. So this would be a 365 is equal to 0.1 times e to the 0.01 times 100 is just 1. So that would be e to the first power plus c. Now, if you'd like, you can plug in this first term on the right-hand side into a calculator, or you might just remember that e is roughly 2.7. So this would end up being a 0.27 plus c, if I'm rounding a little bit. And now I can subtract the 0.27 from both sides. That would tell me that sorry, someone is mowing outside of my apartment, so hopefully you can't hear that. But we get 3.38 is equal to c, and that means that we found our price function. So we know, or sorry, this is a price supply function. So we have that the price at x units per week is equal to 0.1 times e to the 0.01x plus c, but we just found that the value of c is 338. So that answers the first question. And now to answer the rest of it, remember that what we were looking for is first the price supply equation. That's what we just found. And then lastly, we need to know how many tubes would the supplier be willing to supply. So in other words, what's the x value whenever the price is $3.98. So in order to figure that out, what we would do is we would say if p of x equals 398, we need to find the x value. So what we would get is this equation. We would say that 398 is equal to p of x, which is 0.1 e to the 0.01x plus 338. And now our goal is to solve for x. So this is just an exponential equation. We're going to first isolate the exponential term, and then we'll take a logarithm to get x by itself. So I would subtract 338 from both sides. That would give me a 0.6 is equal to 0.1 e to the 0.01x. Next, to get the exponential factor by itself, you can multiply both sides by 10. So that would give you 6 is equal to e to the 0.01x. Sorry, I'm again running out of space here. So once you have an exponential by itself, if you want to get at its exponent, you would apply the natural logarithm to both sides. So we can take ln of both sides. Whenever you take ln of e to the something, then the ln and e to the something, they cancel out and just give you the exponent. So this would become ln of 6 is equal to 0.01x. And then as your last step, you can divide both sides here by 0.01, which is equivalent to multiplying both sides by 100. So you would get that x is equal to 100 ln of 6. And I would be fine with you just leaving your answer in this form. You could punch this into a calculator to get a rough number of units. If you do plug this into a calculator, you should probably round this to the nearest whole number, just because x is supposed to be representing some number of units per week. But I don't mind if you just leave this in the exact form 100 ln of 6. Okay, so that answers the questions that we were looking for. That last part was just sort of review from your business algebra classes. So you might, if that was a little too fast for you, you might look up some solving exponential equations videos. But the main thing here is that we were using a u substitution in order to be able to perform this integral in the first place. So we don't know off the bat how to integrate e to the 0.01x, but we can do this u substitution to first simplify the integral, and then we can compute the integral. Okay, but otherwise, this is just putting together strategies that we've already talked about. So that's the end of section 4.2. In section 4.3, we will start talking about, what is 4.3? We'll start talking about something new. And